2013 polar FRQ. So in this problem, we are given, again, two polar curves. We've got r equals 3, that's the circle, and r equals 4 minus 2 sine theta. That kind of looks like a cardioid in that it's not quite a circle. It kind of dips in this region right here. So the curves intersect at theta equals pi over 6 and theta equals 5 pi over 6. Really nice, again, that they give us these theta values. It's one thing we just don't have to trace for this. Now it said let S be the shaded region that is inside the graph of r equals 3 and also inside the graph of r equals 4 minus 2 sine theta. Find the area of S. So when they say the area of S, I'm just going to outline that area in blue. There is clearly symmetry in this shape. But what I'm going to do is I'm actually going to cut this up differently because I just want to show you another way that you could do this problem. So what you will notice is that the bottom of this shaded region is all defined by the circle. So if I want to find the area of that pink part, I can just do the area of the semicircle. So our total area, I'll start with this part here, this semicircle, would just be 1/2 pi r squared, and we know our radius is 3. Okay, so that's going to give us the pink part. Now, the part above it, this part up here, now I'll outline this with purple. There's symmetry to this. What I'm going to do is I'm going to find just half of this and then I'm going to double it. What we have here is I've got part of this area, or this part right here, is also defined by the circle. But I would need to have this theta value, and that will give me that piece. That will be 0, and again, you could verify that by tracing it. So between those two theta values, shade that in with black here, I would do the integral from 0 to pi over 6 times, of 3 squared d theta. And now technically I would need a 2 times a 1/2 in there, but that does just 0 out, or it equals 1, and 0 out. And I'm multiplying by 2 because I'd also need this area over here. The last piece I need for this is this part right here. That goes between pi over 6 and whatever this theta value is right here. I'm just going to verify that real quick on the graph, which I have up here. I graph the two functions. I'm going to hit trace, but I want to make sure I'm on the 4 minus 2 sine theta, and I'm just going to arrow over until we get to that y-axis. See where we're at. And it looks like it's at 90 degrees, which is pi over 2. So it's always important to verify. Don't assume that that radian value is going to be what it looks like. So for this part, I'd do the 2 times 1/2 times the integral from pi over 6 to pi over 2 of 4 minus 2 sine theta squared d theta. And adding up all 3 of these components, we would get 24.709 or 24.708. For this problem, this is a 3-point question. And 3 points, 1 point for your final answer. And then the other 2 points would depend upon how you solved it. So in this case, probably a point for having the integrals right and then also having the half circle right here. Next question, question B. There we go. Question B says a particle moves along a polar curve 4 minus 2 sine theta, so that at time t seconds, theta is equal to t squared. Find the time t in the interval between 1 and 2 for which the x coordinate of the particle's position is -1. All right, so first thing we need here, so we're talking about the x coordinate. The x coordinate is defined by the equation r cosine theta. So I'm going to need to plug my r equation in for this r. So I have a formula that gives me the x coordinate. So that formula would be 4 minus 2 sine theta times cosine theta. Now, what gets weird about this question is that the question turns from being about theta to being about t squared right here. And it's asking us to find for what value t is the x coordinate equal to -1. So what I'm trying to do is I'm trying to figure out where x of t is equal to -1. But I first have to come up with an equation for x of t. X of theta is up here. Well, I know that theta is equal to t squared, so I'm going to take the t squared and I'm going to plug it in for each of my thetas. And then I'll have a function for x that's in terms of t. So I have 4 minus 2 sine of t squared times cosine of t squared. And I want to know when this is equal to -1. So you're probably wondering, how on earth are we going to get this? To be able to solve this equation using our calculators, because we don't want to do this by hand, this is going to get ugly. In order to do this on our calculators, we're going to have to do this in function mode. So as soon as you get your equations for x and y, make sure you go back to function mode. So here's what I'm going to do. Change the mode. I'm also going to go to radian mode. And I'll be in function mode. I'm going to go back to y equals, and I'm going to put this x of t equation in here. So I've got 4 minus 2 sine of x squared times cosine of x squared. Now I'm going to do one more thing here. I want to know where this function is equal to -1. It's equal to -1 where we find their intersection point. So I'm going to graph -1 and I want to find the intersect. Before I hit graph, I'm going to set up my window so it's in a position that will help me find this t value. I'm going to use this hint in the problem that t is between 1 and 2. And I'm going to set my window between 1 and 2 on the x min and the x max. So I'm going to go between 1 and 2. Maybe go up by 0.2 here. And then the x min and x max, I need to make sure that I have at least -1 in there. So maybe I can go between like -3 and 3. That should be enough to graph this. And I get these two functions. Now the blue function is the equation for x. The -1 is the red. Now I want to find their intersection. Second trace, 5 is intersect, enter, enter, enter. And we get that t is equal to 1.428. Or we could do 1.427. The reason we had to be in function mode was if I hit second calc or second trace, I get all of these options. We can't do the intersect if we're in polar mode, so we have to switch it back to function mode. As far as points for this problem, this is a 3-point problem. We've got a point for defining x, a point for setting up an equation after plugging in the t's and setting it equal to 1, and then a final point for the answer. On to C. It says for the particle described in part B, find the position vector in terms of t. Then find the velocity vector at time t equals 1.5. So find the position vector and the velocity vector. Well, we found x by using r cosine theta, and then we plugged in t squared for theta. So we got x of t is equal to 4 minus 2 sine of t squared times cosine of t squared. And now we need to do the same thing for y. So I'm going to use my y equation, which is r sine theta, which would give me 4 minus 2 sine theta times sine theta. But now I'm just going to rewrite it in terms of t by plugging t squared in for theta. And again, that's going back to this, that theta is equal to t squared. So we get 4 minus 2 sine of t squared times sine of t squared. So our position vector we want x of t comma y of t. That position vector will be 4 minus 2 sine of t squared times cosine of t squared, comma, 4 minus 2 sine of t squared times sine of t squared. And that's our position vector. Now if we get the position vector, this was worth 2 points. Right here, for our last point, it says find the velocity vector at t equals 1.5. So what we're looking for is v of 1.5, which means the velocity is the first derivative of our position vector. So I'm looking for x prime of 1.5, comma y prime of 1.5. These are numbers. Do I want to calculate these numbers by hand? Absolutely not. We want to use our calculator. So I'm going to go back to my calculator and y equals. I'm going to leave my y sub 1 because that's my x of t. And now I'm going to put y of t in for y sub 2. So we got 4 minus 2 sine of x squared times sine of x squared. I'm going to quit out, and now I want a derivative at a point. So I'm going to use math 8. Math 8, in terms of x, we're going to bring up alpha 1, y sub 1, and then I'm going to plug in 1.5. Calculator does the work. So we get our x component to be negative 8.072. Now we'll do the next one. Math 8, x, alpha trace to get y sub 2 at 1.5. And we get negative 1.672, or we could round that differently to negative 1.673, but this first value does have to be negative 8.072. Again, the calculator did the work. That's our final point.